Great. Thank you very much for joining us. Thank you, Prof, for giving us this opportunity to have you on. I know you are very busy with the beginning of the year and, to get everything to work, especially during these challenging times. So we appreciate it. Just waiting for time to, yeah, I think it's time. I'm wondering why I don't see you on stage, Prof. Because if your video feed is going to be live, you should be thrown to this stage with me as well. Yes, for sure. You have the right to speak. So when you activate those rights, you come on the screen as well. I guess it's important for people to see that you are already with us. Well, at least I address a few housekeeping issues. So yes, to just be sure that you are available and you're going to be with us. Okay, so did you join with the link via the speaker's link? Because it should have got you here. So because if you use the speaker's link, should get you to the stage meetings. Right, and yeah, that works. So yeah. However, I didn't see voice. Oh, thank you, Prof. That works.
Can you hear me?
Perfect.
Can you hear me?
Yes, I can.
Okay, very good. Okay.
Yes,
good.
I can hear you. You sound very clear and everything is working. So thank you very much for joining us. How's Durban today?
It's a little bit overcast, but it's okay. It's not too hot for a change. Yeah.
Yes.
Thank you.
That's our best beach, the warmest beach in the world. That's all I remember. I've passed through Durban sometime going to Port Shepstone. I'll never forget the beautiful views that I saw. And how do you live every day? How do you live every day with those beautiful views?
Yeah, what can you do? I hope you will be able to visit us soon.
Great.
As soon as we all have the vaccine.
Very true. At the moment, things look very, very bad here in Zimbabwe as well. We are on total lockdown.
Okay.
And we have seen cases escalating. So yeah, we're waiting for the vaccine as well, anxiously.
Yeah. No, we're all in the same boat.
Sure. Being neighboring countries, we definitely are in the same boat and are going to have to fight it together as well.
Yeah.
All right. So welcome everyone to OneCondom Africa weekly meeting. Today we've got Professor Francesco Petruccione from the University of KwaZulu-Natal to discuss how we can improve quantum in Africa. But before he comes on, let me introduce myself. I'm Farai Majandu. I'm the president for OneCondom Africa. I'm based in Zimbabwe, so I'm actually joining you from Zimbabwe right now. I studied at WITS, did experimental physics at WITS, and I've got a master's qualification from that. Went into community building, which is what I'm doing now with OneCondom. OneCondom is a platform, is a global community which brings people together regardless of their background to equip them with the resources and to connect them to the global community in quantum technology. And OneCondom Africa is our effort to give that same support to people in Africa so that they can contribute to how this technology is unfolding, and they can also participate in key roles in quantum tech. And in order to achieve that, we provide people with resources, digital resources, with mentorship, with financial support, internships, career guidance, and we run events like these meetings where we can discuss. And we also run summits where people can showcase. We showcase the African talent. We showcase the talent in quantum tech. It could be in women in quantum, which is what we have been doing. And some of you may know of our efforts for the women in quantum, which has done very well. And talking of the women in quantum, we've got an event coming in March, and we'll share details via the newsletter and our various channels. So on this for this event, on your interface, you are going to see that there is an icon for the mic. You can grab that one when it's time for questions, and if you need to shout out, and if you need to also contribute to this discussion. We encourage everybody to come through. It takes everyone to make quantum work. It is an open technology which allows everyone to contribute and to shape it so that it can create the right impact in our society. So I encourage suggestions. I'm also going to be running polls. So if you could help us to just understand a bit about you and about what you want to see and any other suggestions that you have. For suggestions strictly, we've got different channels where you can do that. You can do that in the comment section. You can also use, we usually provide in our newsletter a link where you can go to a form and you can provide feedback. Next week, we are going to have a OneQuantum profile share where somebody from Africa comes and share their background and their work so that we celebrate and we showcase the efforts that are being made in Africa. So we've got Oluwani from Nigeria, and we're going to share finer details in our various platforms and in the newsletter as well. So now that we've got about 13 people already, let's go for a group fee. So, Prof, we usually have a group fee here. It's a selfie for a group. It allows us to capture memories and to just show that quantum is cool. So I hope you will be comfortable with that as well. It's a way to take away memories for you and for the community. Sure. Thank you very much for that. So I'm going to start a group fee. And if you guys can come, can accept it in your cameras, and we get to just, capture a moment, and we're going to be able to take away memories on that. So I've initiated a group fee. If you could, come through and let's share a moment. The 13 of us that I see here. That would be beautiful. So don't worry, it takes a bit of time to sort things out. And I think for me it's working here. I've chosen what I think is a photo I want to use. And you can do the same as well on your ends. And let's see how that works out. Let's see how that works out. Okay, so while that is happening, I'll also be thank you, 5 people. Let's get to 13, 6. Thank you very much for that. Thank you very much for that. Yes, 8 people. Let's get to 13 if we could. It's a beautiful, beautiful moment. You will love it, believe you me. For some of you, I think you've seen those on our social media channels, and they always are a hit with people out there. They like them as well. Okay. I'm back. My connection was just not behaving. So the group fee will be sent on your emails. Perhaps let's proceed in the hope that you can hear me now. So you can hear me, Prof?
Yes, I can hear you.
Sure. So anyway, let's recovering from that glitch. I want to introduce Professor Petruccione briefly. He's got a long introduction. If I wanted to go through everything, it will be boring for you guys. I'm going to share a link to his profile as we go. So Professor Francesco Petruccione is based at the University of KwaZulu-Natal. He's a professor of theoretical physics at the University of KwaZulu-Natal in Durban. He set up the Center for Quantum Technology, and in 2007 he was granted the South African Research Chair for Quantum Information Processing and Communication. At present, he is the Pro Vice Chancellor of Big Data and Informatics at UKZN, and also an interim director at the National Institute for Theoretical Physics. He's also an adjunct professor in the School of Electrical Engineering of the Korean Advanced Institute of Science and Technology. We thank you, Prof, for your time, and thank you very much for doing this with us. We want to learn how we can make quantum tech work in Africa. And perhaps to start that, we always want to take advantage when we have experts on this platform. Can you take us through the basic concepts of quantum information processing, what it is and why it is a big deal for Africa and for the world in general?
Thank you very much, Farai. It's a pleasure to be here, and it'll probably take a while to answer your question. And you know what we need to do to make quantum technology a success in Africa. Has probably a very simple answer, yeah, and a very simple answer is that. Sorry, there is a little bit of an echo. The very simple answer is that it will be young people like you and probably like people in the audience that will have to make the difference. Yeah. But let's start from the beginning. Yeah. Farai, there is a suggestion that you should switch off your mic because there is a feedback.
Sorry.
Okay, I don't know. Yeah.
That's okay. Because I lost the connection, so it's activating again. So I'm shutting down. Thank you.
Okay, great. Now, so you want me to start by giving an overview of quantum technology? Okay, that's fine. You know, quantum technology. What we understand in this context under quantum technology is probably the fruits of what some people call the second quantum revolution. Yeah? The first quantum revolution was approximately 100 years ago. Yeah, so not even I was born at that time. Yeah. And it was the advent of quantum mechanics, the Schrödinger equation, Heisenberg uncertainty principle, and all tunneling and all those kind of things. Yeah, and already the first quantum technology revolution gave us amazing technologies. Yeah, just think of the laser, diodes, or things, or transistor for that matter. Yeah. That kick-started the digital age, essentially. Yeah? The second quantum revolution started a little bit later, yeah? Probably some 30 years ago, yeah? And it's characterized by the fact that all of a sudden we were able to manipulate a single quantum object, yeah, like single atoms, yeah, essentially, yeah. And that was the moment that allowed us to start realizing experimentally many of the thought experiments of the first quantum revolution. Yeah, for instance, Schrödinger and his cat. Yeah, that was just an idea on paper. Yeah, it was just a formula. Yeah, but it was only the moment we were able to manipulate single atoms, single ions, that people started to have the technical ability in their labs to create things like Schrödinger cat states. Yeah, and then of course they got a Nobel Prize for that. Yeah, and for the technology that led to that. Yeah, so that what we understand under the second quantum revolution is what essentially the use of the more magic or spooky, if you want to use the adjective that Einstein used, properties of quantum mechanics. Yeah, like entanglement, for instance. Yeah? So what was just maybe a very odd thing, yeah, entanglement, because it's the expression of correlations between quantum systems that are much stronger than any correlation that we can have in classical systems. Yeah? And it's so odd that people like Einstein didn't really believe it, or find it quite strange. Yeah? But now we know that things like entanglement are a resource. Yeah? We can use entanglement to do things. Yeah? And that's why we are here, because we know that probably historically the more mature quantum technology is probably quantum communication or quantum cryptography. Yeah, because the first protocols were developed in the 80s, and also the first experimental realizations go back a couple of decades, and now you can buy off-the-shelf solutions if you have enough cash and need for a very good security. Yeah? I mean, the other big quantum technology, probably most people that are here in this forum are excited about, is quantum computing. Yeah? And quantum computing is also a new kind of computing based exclusively on the rules of quantum mechanics. So the basic unit of in the quantum computing setup is no longer the bit, is the quantum bit. Yeah, so the quantum version of the bit. And what makes the quantum bit very different from the bit is not that it can only be 0 and 1, but because of the superposition principle and all the magic of quantum mechanics, it can be everything in between, essentially. Yeah, and so that the usual figurative way of depicting a qubit is to think of a little vector from the center of a sphere to the surface of a sphere. Yeah, and all points on the sphere are essentially legal qubit states. So already this simple image that unfortunately doesn't scale up to more qubits gives an impression that the space in which quantum computing happens is much bigger than the space in which classical computing occurs. Yeah? Because instead of having 0 and 1, you have the surface of a sphere. Yeah? So that's makes a difference. Yeah? And exploiting this big space that technically is called Hilbert space is what makes quantum computing so powerful. Yeah? And Farai, I just keep talking. If you if I'm talking too much, I'm too boring, just let me know. If it was essentially one person, Peter Shor, that created all the buzz about quantum computing, because Richard Feynman and other famous physicists had the intuition also in the 80s, that there was something coming, and his thinking was very simple. Nature at a fundamental level is quantum, and if we want to simulate nature at a quantum level, it sort of makes sense that using a computer that operates according to quantum principle should have an advantage on a classical computer. Yeah? But this was just an idea when it came up. Yeah, and then Peter Shor came along. Yeah, and he found the first really non-trivial algorithm that could run on a quantum computer. Yeah, the famous factorization algorithm. Yeah, and so that was a kind of a milestone. Yeah, in this development. Yeah, and the same Peter Shor a few years later came up with a strategy for error correction. So if one day someone is able to build a quantum computer, thanks to Peter Shor, we know how to do error correction, because every computer, be it classical or quantum, will do errors, and without error corrections, it won't be a kind of a universal and useful computer of sorts. Yeah? And and this was, I think, the moment in which people thought, okay, in principle we can do it. yeah, because if without error correction in theory, people would be probably have been a little bit more careful in investing lots of money. But in principle, we know that we can do it. Yeah, and we have already today quantum computers in the cloud. Yeah. There are different companies that offer quantum computers in the cloud. That are at the moment too small, in the sense that they don't have enough qubits to allow the implementation of error correction. So that's why we call them noisy quantum computers. Yeah, because essentially it's like computing without a safety net. If an error occurs, bad luck. Yeah, there is not much you can do. Yeah. And that's where we are now. Yeah, so we know that we have quantum computers that probably many of you have already used. Yeah, and we know that we have lots of algorithms. Yeah, there are even dedicated website. I think that the one is called what's called the quantum zoo of algorithms. Yeah, you find it immediately if you Google a second. Yeah, that lists all the known algorithms. Yeah, and also a few days ago or a week ago, a preprint appeared in the archive, which is supposed to be a review article that summarizes all the known algorithms that have been implemented successfully on the small quantum computers that we have available today. Yeah? So that is the reason why there is so much fuss about quantum computing at the moment. Yeah, because it's a technology that is emerging and has a huge potential. Yeah? Does that answer more or less your question, Farai? Okay, if Farah is not there, I just keep going. I think the
I'm here.
Farah, does that answer more or less your question? Okay, Farah has trouble with his internet connection. If you can hear me, yeah, please tell me in the chat if you can't hear me either. I will
okay.
Just keep going.
Can you hear me, Bob? Can you hear me now?
Yes. Yeah, now I can hear you. A little bit disturbed, but I can hear you. Yeah.
Okay. So
Okay, let me keep going. I think the
okay,
next the sub question. Yeah. Okay. Okay, I think I keep going until Farah sorts out his connectivity issues. I think the sub question that Farah posed was why should young people be interested, and what can we do to? Sorry, I think he asked what can we do to improve the quantum computing community in Africa. I mean, Farah mentioned that at UKZN we started with this quantum technology business in around 2006, 2007, or something like that. Yeah, so that we've been promoting quantum computing and quantum cryptography for about for quite some while. Yeah, and one of the things that we have done, I think, quite successfully, was that we started around that time a conference series that we call Quantum Africa. Yeah? And the explicit intention of the Quantum Africa conference series was to slowly build an African community around quantum technology, yeah, and we call it just Quantum Africa to have a catchy name, like there is Nano Africa, for instance. Yeah? And the first couple of editions we did in Durban and surroundings, but then we started organizing the conference in Morocco. We had a conference in Tunisia. Then we came back to South Africa in Stellenbosch. And this year it's supposed to happen in Rwanda, yeah? But we will see how if the organizers decide to organize it online, because probably not many of us will be able to travel to Rwanda this year. And but I hope that the conference will move to an online format, and I hope that Farai and OneQuantum will become sponsors or co-hosts or whatever, or involved in some way in the organization. Yeah? So that was one thing, just to reach out to the African continent. In parallel to that, we also have almost bi-yearly. Yeah? I think last year we didn't have one because of COVID and all the rest, but this year we should have one in any case, probably also online, a more local South African conference on quantum computing and quantum technology in general, just to bring together the whole South African, at least, quantum technology community. Yeah? So that once we know if we organize one this year, we will let you know, Farah, so you can distribute the announcements in through your channels. Yeah? And sorry, I forgot. I mean, and also over the years we've organized many summer schools, yeah, on various topics on quantum technology, yeah, from general open quantum systems conferences to general foundations of quantum information processing. We had a very successful summer school on quantum machine learning that was really instrumental in kickstarting the quantum machine learning community worldwide, because it was the first school on quantum machine learning, yeah, and other things. Yeah. Recently, we were quite lucky to get a grant explicitly to do training events in quantum technology. And because of the pandemic last year, we were not able to do them. But this year we will do it in any way, either after we are all vaccinated or in some online format. Yeah. Yeah. So these are things that have been going on since the very beginning of quantum technology in South Africa. Yeah. Another thing that might interest your community, Farah, is that last year government, specifically the Department of Science and Innovation, tasked a team, and I'm co-chairing the team together with Zeblon Vilakazi from WITS, to write a kind of a framework document for the country for the adoption of quantum technology. Yeah? And we have already almost completed the work, and in fact, sometimes in February we will present it to DSI, and if they approve it, we will have an